All right. Good morning, everyone. Sorry for the delay. I had issues connecting to the infrastructure at EURECOM. So the whole presentation turns out to be a video at the end. I'm sorry for that. But this was also the similar demo we showed a few days ago in OAI workshop. Here, to start with, I just wanted to give you a more conceptual view of the infrastructure, how it is established. So essentially, there are different regions in the cloud. So here, for instance, we are seeing in this example 4 areas. So one, I call it more like a DU pool, where you have a bunch of DUs running one or many. Then you have a CU pool, where the centralized unit is running. Let me get the light here. Then the core network pool, which actually runs the core network. It's possible that, for instance, the UPF of the core network is running in the CU pool, right? This is so you could somehow put all the control plane of the core network on core network pool, and then UPF, for instance, could be here. Another region is more from the controller management. So it is not mixed. There is a lot of echoes, by the way. Yeah. There is, yes, there is this area where I'm putting RIC, I'm putting the operator. So operator is more about the management and operation of the network. RIC is more about the control. So they are in another area, and you see also the XApps and the SDKs are running in this area. And then you have the RUs that could be directly connected to the DU or could be transported through the fronthaul interface, right? So fronthaul could be any type of fronthaul. What you see underneath, we have also a switching fabric with the BGP, and as well there is also a PTP groundmaster that is actually transporting the clock, the synchronization, towards the radio unit. Another observation here is that different regions, they might have different resources. So here I'm showing it with the circles, square, or triangle. So some of the DUs might have some accelerators, some specific FPGA card, for instance, that are also specific to each area. So one nice thing about this architecture is that this operator is interacting with the hub. So this hub, you could imagine like a Docker hub or more private hub, where you have the image or artifact registry. And this operator is able to fetch those images from the hub and then deploy it in the relative infrastructure, depending on where it is, the core network CU or CU. So what we are going to show, we are going to position ourselves in a remote control mode. So we are having a CLI, command line interface, to this operator, which is the front end to access everything. So this remote control gives us some control commands that we could exercise on the infrastructure. Very easy. So, and this, I'm going to show you some CLI commands that we have implemented so far to access the whole thing and control the whole thing. I just wanted to mention that there are 2 stages in the whole process. One is the stage of the devs, whereby there is packaging, testing, and distribution, which happens on the upper part. So in the upper part, you have a Git, the source code, you do CI and some unit tests, you do CD and end-to-end test, and then you release in the artifact register. So this is the dev part, and there is the operational part, which is the second half of the figure that you see. It's more about the operation of your network in the actual infrastructure. So you have a provisioning phase, which you see here, we are using Cloud Init to provision the infrastructure. The second is the automation, which use this operator through this remote control that I just showed you to access the infrastructure. There is a control and there is observability. Observability is a new term that replaced monitoring. Monitoring is an old term in a sense that it's more like a passive of monitoring of the data that is coming from the network. Observability is incorporating more active monitoring in the sense that you could apply some actions or some alarms on some events that you are observing. So that's why you see here the term observability here. So this is just, and all of this is nothing new here. All of these are the GitOps methodology that you see here. So if you just Google GitOps, you will actually find the same type of methodology here. I just try to visualize it for you in a better way. So the commands are very easy. For instance, here you have a command that is called P9S extract infra. So the first thing you want to do, you want to see what do you have in your infrastructure. So infrastructure being this bottom part, right? This bottom part, you want to see what do you have? What kind of resources do you have? What are the machines? What are the operating system? What do you have, right? So we are gonna see in the video, we are running this extract infra. So this is a console. And let me, so here we are gonna run T9SCTL extract infra. And it gives us something like this. Let me just remove it somewhere else. Yeah. So what we, okay. So what we see here on the top, we have Kubernetes control. We have 3 machines that are acting as a Kubernetes control. This is because of the redundancy. So we have 3 machines playing the control plane of the Kubernetes for the whole cluster. And here we see that the name of those machines, the IP address, the operating system, the runtime. So here is a Docker. It could be a Podman container D. We also see the compute. You see here you have a system, the compute, what kind of architecture they have, the number of CPUs and the memory. And we also have the radio. So for instance, we have in this machine, hold on, we have 2 Amarisoft SDR, 1 USRP B200, 1 N300, and 2 QuickTel. QuickTel is the user equipment. So we could actually probe. There is a discovery process behind the scene that actually discovers what kind of resources do you have in your infrastructure. You also see here the IMSI list of those QuickTels that are actually attached to this particular machine in region 1 or site 1, and you see site 1, site 2, and site 3. So using this command, we could actually extract an actual snapshot of the infrastructure that is actually running. So this is the command infra. Again, I just want to stress that this command also gets the, if there are some infrastructure user equipment, it also extracts those things. Here you see the QuickTel is part of the user equipment, but we actually extract that as well. So this is the description of the deployment of OAI with the RIC. So essentially, we divided the descriptor into 4 domains. So one domain is of course, the radio access network domain, which we call access. You see here access, the access domain. We have a core domain, which maps to the conceptual architecture I showed you before, different cloud regions. We have an edge domain where FlexRIC is gonna reside. And there is also terminal domain where the terminals will reside. So we are conceptually separate these domains in the descriptor. So the descriptor understand, okay, I have an access network. It is called OAI RAN. The stack that we are gonna deploy is the 5G standalone. The model is OAI RAN model. So let me give more details about here. What we observed is that there is a decoupling between the deployment blueprint and what you want on the access domain or core domain. So we decouple the descriptor of the deployment. For instance, here we have RAN model. So this OAI RAN model, it has its own descriptor that it says, okay, this RAN is going to be deployed in certain way. And this is more about the configuration of that RAN model. So we decouple the deployment from the configuration. They are not the same descriptor. So essentially, you could apply the same configuration for different RAN models. So you have monolithic RAN model, you have a disaggregated RAN model, together with what type of container runtime you want to have, Docker, Podman, which is one descriptor. You don't see it here. And then there is this descriptor that describes more about the networking, about the radio, and many configuration files that we abstracted out. So here you only have few configuration files. And this allows for vendors like, for instance, OAI, Amerisoft, SRS, or other type of software to describe the deployment model they are supporting. OAI could, for instance, say, I have monolithic support, I have disaggregated support. Amerisoft will say, I don't have disaggregated, I just have simple RAN. So they describe their deployment, and you as a user, you describe the configuration you want. Which band do you want? Which PLMN do you want? So you don't actually take care of deployment blueprint. That is done already by the vendor. That is the mentality here. So here we see, and we see that here in the access, it says controller is FlexRIC. So it needs to get connected to the FlexRIC. So we also defined a slice. So we have the specification for the slice, for instance, the APN and what kind of the service and so forth. At this level, it's more about the placement from the Mano perspective. It's don't mix this with the 3GPP. This is just a descriptor that is passed, right? So we have the access that, for instance, gives, okay, I want to monolithic with the E2. So this is a deployment mode that we want monolithic OAI, just G-Node V, no CUDU, but we also want E2 interface. These are the band 78, for instance, the interface. And we also say the region that this needs to be deployed is site 1. We also describe where you want to deploy it, right? There is this possibility to describe the region. Then you have for the core that you see, here the core, for instance, in OAI, there is minimal. Minimal means there is only AMF, SMF, and UPF, right? Minimal deployment. There is no UDM, there is no other functionality. And this is the part that describes the terminal. So we also say we want to inject one terminal into this infrastructure. So this terminal, for instance, it has certain information, and this operator will actually provision the database and do whatever needs to be done to authenticate this user. So now that this you saw this, the next command is the observe. So observe is basically observing what's happening in your system, right? So obviously, when we see in the observe, there is no element deployed, there is no network, and there is no terminal. And these are the previous logs from the previous deployment. So when you do the observe, you see that nothing is deployed, the timer is 0, and this window is also about the alarms and the events. So now we go to another command, we install the network. You see the command is very straightforward. You just say T9STTL install network, and you give the blueprint that we just saw before that has access, edge, core, and also the terminal, which is more about, again, configuration. It's not about the deployment. The deployment is already described by the vendor. So here we just say to T9S, the CLI of the operator to install the network for us, right? And look at the timer as well. So this is the timer that we also start to show the time it takes to deploy the whole thing. You start, we run the command, we go to observe. Already things are installed. You see on the top, we have FlexRIC, AMF, DB, GNodeB, SMF, UPF. You see all them. You also see the terminal here. We have also one quick tell here that is part of the infrastructure that is also here. And we see that the state of most of the elements are becoming true. And we also have quick tell that you see here. It is also part of the elements of the network. So it is as if you bring the user equipment into the manual. So now we will be seeing that the user is gonna get connected. So this is true. You see, at this moment in time, when the status of the user becomes true, we had 52 seconds to deploy the whole blueprint that you see here. From nothing to user being actually connected to the network. So the way we measure this is that we actually perform a ping to make sure that the user is connected. So this is not just a control plane connectivity, but actually is a user plane connectivity. And you see that it's quite fast. It's quite fast. Now we continue. So the status is true now. We want to extract the logs. So you deploy something, but you want to see some logs. What happened in the network? I want to see the log of the core network, log of the OAI, log of FlexRIC, whatever you want to do, right? So now we do the log of, for instance, FlexRIC. So in the log of FlexRIC, what we see is that, as I said, in FlexRIC, all the service models are pluggable. They are not, they are shared libraries. So you see that here, the relevant service model loading SMID, all of these are loaded. And now we are saying that accepting run function ID with this MAC status. So now it's starting to report. So we are actually from T9S, one thing you need to understand here is that the infrastructure is somewhere you don't know where it is. The CLI is on your PC. And this command automatically connects to the right pod, right container, gets the log for you, bring it back, right? So you don't need to know where is that container where FlexRIC is actually running. You don't see it here. T9S is doing it for you. It go and get the logs for you from that container in a bigger infrastructure. So many levels of abstractions here have been done. Now, another interesting command is that before I showed you the infrastructure, right? What kind of regions do you have? What kind of machines do you have? Now that the network is deployed, you also want to see what is deployed. What is the network topology, right? This is another command. It is called extract graph. You run this command extract graph. It extracts you what has been deployed for you on the infrastructure. So here, what we see, you have a namespace, you have a terminal part, you have a network part, and then you go to the elements, you go to the pod, you go to the container, and inside you have all your services that are propagated. This is very flexible. This is one way of representing the graph. For instance, you can see here OAI AMF. For instance, I don't know if you can see it from there, but I can read it from here. Is the QuickTel module deployed in this pod, for instance. And this is region 1, for instance. This is another region. This is another region. So these are also shows the mapping across the region, across the sites, what service deployed in which pod, which container, which namespace, which is quite useful. Okay. Again, we are back to our environment that is running. So now this is about removing the network. Now that you, for instance, you deployed, you check the log, you can now remove your network. So it's more like it's part of an operation, right? The operation means you install the network, you observe the network, you get the logs, you measure the things, you get the graph, you get the information. Now we are removing the network. So we clear the timer. We start the timer, we remove, we go. And it's very, very quickly, the whole blueprint is deployed from the infrastructure. Very, very powerful. So if we see the commands, so this is like a minimum commands that so far we have developed. So one is CIC, so CLI and CLI. So one nice feature is that some of the softwares, they provide you some command line interface. For instance, you run OAI. OAI has a command line interface. You run Amarisoft, you run SRS. They have some command line interface for their software. So from T9S, you can get access to the command line of the software you are running in some pod program that you don't know where it is, right? Probably your SRS you run in some of the pods, and from T9S, you can access the CLI of your application. Again, you don't need to know where is that pod, where is that container. So it has the generation of the auto-completion script. So this is the standard things. Extract, the one that I showed you, extract the content of your network topology that is deployed. The installation, install a component. The observe that you saw the window, the remove. There is a search, list of all the models. And there is this function that is very interesting. We are still working on it. It is working. This is a test. So you could, from T9S, perform a test and measurement. You could say, okay, perform an iPerf test between this network and this user. So from here, what happens behind the scene is that 2 new pods is created for testing purpose, injected with the right application and for the thing, and the data channel is established, measured, brought back to this command line, and then the whole thing is finished. Yes. So let me see if I have anything extra to tell you. Yes. So for instance, this is one of the specific commands for CIC, CLI and CLI to get, for instance, the NG connectivity of the RAN, which returns you whether the RAN is NG connected to the core network. This is the standard CLI that is available for this stuff. I think with that, I finished this video demo. Again, sorry for not being able to remotely show you. If in the meantime I get connected, I will show you a sign. You can come to my PC. I will show you in live, right? Thank you very much. Any?